guys, Mrs. Traver here. Today we're going to talk about multipliers. Our learning target is to be able to write exponential equations given substitutions. What? Hey guys, Mrs. Traver here. Today we're going to talk about multipliers. Our learning target is to be able to write an exponential equation given different situations and tables. You know you'll be successful when you can identify the initial amount and the multiplier in both those situations. Let's jump in. The situation we have first is a store expecting to start selling 100 cell phones on launch day, then expecting to sell an average of 15% more every week after that. Let's get started and remind ourselves of the equation for exponential functions. It's y equals ab to the x, where a is the initial value, or also called the zero value. What? Zero? Here's our first situation. A store expects to start selling 100 cell phones on launch day, then expects to sell an average of 15% every week after that. Our situation for this is an exponential function with the relationship y equals ab to the x. As a reminder, a is the initial value, also sometimes called the zero term, and b is the multiplier. Let's set up an equation with each of these and find a and b first. So a in our situation is the initial value, which we're expecting to start selling 100 cell phones on launch day, day 0. So a is 100. B is this percent 15 more. Now we have to be really careful, 15% more every week. Now if you stayed the same, it'd be getting 100 cell phones sold each day, but we're getting 15% more than that. So if we stayed the same, we'd have 100% of the cell phones from yesterday, but we have 15% more than 100% of yesterday's cell phones. So we really want to talk about 115% of the day before. I should say week before, since we're doing weeks. So our change is 115% increase. So what we can do is write that as a decimal, which we move the decimal twice to the left to give us 1.15 as our multiplier. Let's write the equation. We have y equals 100 times 1.15 to the x. Next, I want to find out how many will be sold after the 4th week. Now let's see, if we put a 4 into this spot, we'd have 100 times 1.15 to the 4th. I'm just going to use my handheld calculator this time for ease of writing it on screen. I've got 100 times 1.15 to the 4th, which I get 174.9. So I know this is a decimal, but these are all approximations, so it's okay if we leave a decimal in for now. Here's the problem. We have another cell phone company, and they plan to send 10,000 pre-orders in week 0, and then they have sales increasing by 7% each week. Let's write an equation for them. This is a company. Our first one was just a store, so they've got some big bucks here being sold. Our equation in this case is y equals, our first term is the 0 value, or the initial amount, which is 10,000, times the multiplier, which we're increasing by 7%. So we've got 107% increase each month, which I could write as 1.07. So times 1.07 to the x. I also want to know on this one is how many they will sell by week 4. So in our case, we'd plug a 4 into the x. So y equals 10,000 times 1.07 to the 4, because we're going by weeks. Let me put this in my calculator. 10,000 times 1.07 to the 4th. I have a total of 13,107.96. Really, I should say 0.8. Let me go back and erase my last digit here. There we go. So that's how many phones they'll have after week 4. Now, these two companies are kind of going head to head. So in comparison, they had a bunch more phones. Let's try it from a table. If this was our situation, we have n and t of n. Let's be really careful. This time it's not x and f of x, it's n and t of n, which we know these are sequences. So right off the bat, we know this is a sequence since it's using t of n, which our equation for those looks like this, a times b to the n. In comparison, on the last problems, we had equations that were functions, f of x equals a times b to the x. They both grow the same way, but with sequences, we don't have any numbers in between. It's one number, then the next, then the next in a sequence. So this pattern goes 1600, 2000, 2500, 3125, and so on. So let's find a and b all the same for our sequence. A is the initial value when there is 0. So that would be right here. There's my A. B is what got multiplied by each time. So I just need to find that number. Then when we go to the next term, what got multiplied? What we can do is divide to find it. So if we pick two terms back to back, 2500 and 2000, for example, it doesn't matter which ones you pick. If you divide them, which let me do now, you'll get 1.25 for this situation. And you'll notice that works. If I were to multiply 2500 times 1.25, I get 3125. It works every time. So this is my B term. My equation now is T of n equals 16,000, I did it again, 1600 times 1.25 to the n. All right, here's another one. Let's see what we can do with it. We have T of n, so a sequence again. And let's find our initial value. That's where n is 0. So here's my initial value, 3,906.25 times our multiplier. Let's find that. I'm going to pick two numbers next to each other to divide. I'm going to choose these two. It doesn't matter. I've got 2,000 over 2,500. That's actually the same as the last one. I just realized 1.25 again. So times 1.25 to the n. Here comes our last one. I see my 0 value already is 50, so T of n equals 50 times our multiplier. Let's find that. I'm going to use 72 over 50 to find it. So 72 over 50 is 1.44 to the n. We can always check this to make sure we're right. If I were to plug in a 3 to my n, I should get 149.2992. Let's make sure I do. So I'm just going to type it in my calculator like that. 50 times 1.44 to the third. And there it is, 149.2992 exactly. That's all I've got for today, guys. I hope the multipliers are making sense. Again, we're finding the initial value as well as the multiplier in each of these situations. I'll see you next time.